find the resultant and its distance from A. Okay, so this is the point A. The distance between each of the forces are mentioned like this. So this is 21 Newton, this is 16 Newton, 40 degrees, this is 2 meters. Then there is a point B, this is 4 meters, 83 Newton at an angle 65 degrees. This is 14 Newton, 26 Newton, 13 Newton. Now, if we can see carefully, all the forces are acting on the same plane, but they are not passing through the same common point. Right. So, because of this, now they fall under the category that all the forces are coplanar but non-concurrent. Right. So, the similar problem which we solved yesterday and the previous sessions are applicable over here. Okay, so my first objective is to find the sum of all the forces in x direction. Starting from 21, it is minus 21. Then the 16 Newton is towards the positive side. So this is plus 16 cos 40 plus 83 cos 65. The 14 and 26 Newton will not come into picture. Plus 30. Okay, so this is the summation of the forces along the x-axis. Okay, 45.5 Newton. All right, then R. Okay, theta equal to 48.99 degrees. Okay, so R and theta have been obtained. Now our next intention is to find the distance from A. So for that I need to find the sum of moments about the point A. Okay, now when I consider A as my point of reference, the 21 Newton passes through that, right? It's through the A, so I don't have to write that. Okay, then the 16 Newton right, is actually passing through A. Even if I split that into two parts, that's also going to pass through A, so I don't have to consider that. Then the 83 Newton, right, is not passing through A, but when I split it into horizontal and vertical, the horizontal component will pass through, right, A, so I don't have to write the horizontal, only vertical. So the vertical component is 83 times sine 65 into the distance is 4 meters. Okay, I think the distances have not been mentioned for others. Okay, let me just write. Okay, so the other values are like this. This is 6 meters, this is 2 meters, and this is 4 meters. Okay, so 83 sine 65 into 4 is the distance, and this is upwards, right? Whenever force is upwards, it is anti-clockwise, so positive. Then another force, that is 14 Newton, it's upwards, so it's going to rotate it in the anti-clockwise, so plus 14 into the distance is 6 plus 4, 10. Then we have a 26 Newton, that is downward, so it is clockwise, negative, minus 26 into the distance is 4 plus 6, 10 plus 2, that is 12. Okay, and the last force 13 Newton passes through the point A, so I don't have to write. All right, so calculate the moment about sum of all the moments about A. Summation MA equal to 189 Newton meters. Right. So we, huh, okay. So the distance formula, distance is equal to moment summation of moment of A divided by resultant. Right. Okay. Just one the moment. Okay. So the answer is 2.14 meter. So it makes, right, R, that's the magnitude, theta, which is the angle with respect to the horizontal axis, and located at a distance of 2.1 meter from A. That is the overall answer, right? X and Y coordinates are actually not required for this because, right, we are not measuring anything in the coordinate axis. Okay, let's solve another problem of a similar type. Okay, in this case, find the resultant, find the distance of the resultant from O, right? So this rightmost point is O. This distance is mentioned. You can see that this distance is given. Distance between this and this point is 8 meters. Okay, the 8 meters is the distance between the 2 points. Okay. Okay. The value of fx, sum of fx equal to 96 Newton. Then sum of y, okay, we calculate r equals to, okay, 85.18 Newton, 9.70 degrees. Okay, all right. Now we'll apply the moment summation MA. Now all the forces needs to be considered with respect to O when we consider the moment. You can start from the one force which is at O, that is 108 Newton. It is actually passing through that, so we don't write that. Then there is another force which is 96.85 Newton, making an angle 58 degrees with the horizontal. Right. So this force, direct distance is not known. I can split this into vertical and horizontal. Horizontal force will pass through O, so I have to consider only vertical. When I consider the vertical force, this is 96.85 into vertical means that is sine. Okay, sine 58 degrees. This should be multiplied by the distance from O to that, which is equal to 4 meters. And at O, if I fix this, fix the whole plank, right, the 96.85 Newton is actually going to make it to rotate in the clockwise direction. So this is negative. Okay, then another force. The next force is 26 Newton. So again, that is going to make it to rotate in the anti-clockwise. So I write minus. Okay, so this is minus 26.34, right? Angle given is a 61 degrees with the horizontal. So I have to split it into vertical component, means a sine, okay, into sine of 61 degrees, right? It is upwards. So you can see that this is clockwise. Into the distance is 6 plus 4, so 10 meters. Then we consider the another force, which is 66.45. So it's actually right coming downwards. So it is going to make it to rotate in the anti-clockwise direction. So positive. So plus, this is 66.45. Vertical component, once again sine 70 into the distance is 8 plus 6 plus 4, that is 18 meters. Then there is a force upwards, that is 90 Newton, which is vertical. So you have to write it completely vertical. It is moment is negative because anti-clockwise. So minus 90.18 force into, this is 18 plus 4, 22. Right? And the last force is 45 Newton. This 45 Newton is downwards. So with respect to O, it is going to rotate in the anti-clockwise direction. So that is positive. Okay, and convert this into this 45 into the vertical component, so that is 45.36 sine, this is sine 60, multiply that with the total distance of 22 plus 6, that is 28. So all the forces have been considered, and you can calculate the moment about. So this is minus 318.98 Newton meter, and we can calculate the distance from this. Okay, so distance is equal to this summation MA by the resultant. Minus 3.74 meters. So this negative indicates that the position, this 3.74, needs to be measured on the left side of the point O, right? So you can see that point O is located over here, right? And the distance that I need to measure now, right, the overall resultant of this force system is actually 3 meters to the left. Left side is negative according to this. And if you look at the previous problem, we got an answer which is positive, indicating that the point is present on the right side of the given what you call